right, then this one, the last one didn't show that it went to OneNote, so I don't know what to do. So I'm just gonna go ahead and make this because I've got to get them made. And then I've got Mr. Anderson and Mr. Titshaw and Mr. Hardinger on it. Surely somebody's gonna be able to figure out what to do. It should not be this hard. Okay, next one is the linear pair postulate. And it's just a particular type of angle addition postulate. So, wait, what is on the board? Hang on. Anyway, so the linear pair postulate says, all right, we've got angle AOC, so there's a straight angle. So you know there's 180 degrees in a straight angle. And you pick any point B that's not on that line, so it's non-collinear, and you draw in that ray. Then what we know for sure is that the measure of angle AOB added to the measure of angle BOC, yes, it's the measure of angle AOC, but we know that that's a straight angle, so we know that's 180 degrees, so there's no reason to say just what we would have said with the angle addition postulate. Like, we'd rather just say, oh, they added it to 180 degrees, and we call that the linear pair postulate. Okay, so next part, we got a bisector of an angle. So what that is, here's the definition. It's the ray, or, well, no, I guess we can say the, because you would just have a ray, this one ray bisects an angle. It can actually be, it doesn't, like you can think of it as a ray, but if it was a segment, or if it were a segment, or if it were a line, or if it were even a plane, we probably still would say it could bisect the angle. So the ray that divides an angle into two congruent angles. So you'll start noticing that, oh, I'm looking on the computer. It's that the first set of notes for today, the first page, it says it's almost done. So maybe it's almost there. It took like 4 minutes. All right, so here's what we know about a bisector. So if you have this ray BD, and it comes through here, and we're gonna say that it bisects angle ABC, then that means it cuts the angle in half. What it does is it creates two congruent angles. So if we know that ray BD bisects angle ABC, ABC, then what we know is two things. We know that angle 1 is congruent to angle 2, because that's the definition of an angle bisector. And because we know that, then we know that the measure of angle 1 is congruent to the measure of angle 2, because that's the definition of congruent angles. Okay? All right. Then we're going to go through this. Stop the video, try to answer all these, and then come back and check. So I'm just going to keep talking because I'm just going to assume that you've already stopped your video. And we've got the measure of angle DEB. Okay, so DEB. We're looking at this one. Give me another name for it. Well, really, the only thing else I could call it is angle BED. That's the only two ways to name that angle right there. Okay, next is angle CBE. Okay, so CBE. All right, well, I could extend it. So one thing I could call it is angle, like, say, just CBF. You know, it's a ray, so, ooh, I could call it angle 8. That'd be the easiest one for everybody to look at. I cannot call it angle B because there's lots going on at angle B. I could call it angle EBC. I could call it angle FBC. But you notice the vertex has to be the one in the middle. I think that's it. All right, for the rest of them, I'm not going to really necessarily come up with every single way because I think you're going to have the hang of this. But angle AFD. Okay, so we're looking up here. So why not just say it's angle AFC? That seems easy. Angle 7, all right, right there. Ooh, let's just call it angle C because that is the only thing going on down there. And then angle 9, let's do this right here in yellow. So angle 9, let's just call it angle EBA. Again, there's lots of choices that you could have, but, you know, these are just answers could vary here. This one, you only had to have one, etc. All right, so then the measure of angle 1 plus the measure of angle 2, okay, that's the measure of this big angle. So the measure of angle BAF. And that is the angle addition postulate. Okay. Next up, measure of angle 3 plus the measure of angle 4. That makes this big angle. So the measure of angle, what, AFD would work? Okay. And then the measure of angle 5 plus the measure of angle 6. Ooh, now this is all working all the way. That's a straight angle. So this one, it's the specific type of angle addition postulate. It's the linear pair postulate. Ooh, let's just mark out the measure of and just write 180 degrees. So now if they did need something that said the measure of, then we could call it like angle FDC. It's not that that's wrong, but I think it's actually, more people would just go ahead and say that it's 180 degrees because it's a linear pair postulate. And I'm just going to finish this up. I'm going to put both of these because I'm almost done. Oh, and speaking of which, I'm going to go out of order right here because my guess is you might be going, well, how do you know that's 180 degrees? So I'm going to skip to the bottom and I'll come back. So this is a little disclaimer on, what is it, page 19 in the book, where anything in this textbook or any worksheet that I make you, here's the stuff that you can assume. So, because if we don't just go ahead and assume these things, the directions for every problem would take up so much room. It would be, I can't even imagine how big this book would be. So all the points shown are coplanar. Assume they're all in one plane. Line AB, ray BD and ray BE all intersect right there at point B. Like if it looks like they intersect at a point, they intersect at a point. A, B, and C are collinear. So they're saying if it looks like they line up, if they look like they're sitting on a line, they're sitting on a line. You know, if they draw a line through them, we can say they're collinear. And because it's a line, you would say that B is between A and C, because we'd never say the word between if they weren't all on the same line. Angle ABC is a straight angle. So basically, these three things are saying the same thing in a different way. What else we got? D is on the interior of angle ABE. Yeah, if it looks like it's out in the interior of an angle, it is. And then angle ABD and angle DBE. If it looks like they're adjacent angles, they're adjacent angles. All right. So what it doesn't tell you, though, so all this at the top we can assume. It has to be marked up to go from there. So what they're saying, it does not tell you, even if it looks like AB, the length from A to B is the same as the length from B to C, you can't assume that unless they show it. So they'd have to come through and go, okay, this is congruent to this. And they'll put those tick marks right in the middle of whatever it is that they're measuring. Angle ABD is congruent to angle DBE. Again, I like to put the extra tick mark on it. You don't have to. You can't assume that. Like, if you think they look like they're the same size, you can't assume that they are unless they've told you or they've given you enough information for you to figure it out yourself. Hang on, I'm looking. Oh, dang it. This is just the one on the videos, and it's been sitting almost done for quite some time now. So how is it working worse today than it has? I don't understand this video situation. But hopefully the tech folks are going to figure it out for us, Ethan. And I'm so sorry that we're having such a slow start. I've done all this stuff at other schools, and I've just never done it on an iPad. And Mr. Anderson thinks the iPad is the problem. He thinks that I'm going to have to figure out something else. But I just think we should be able to make it work. We just got to figure out how to make it work. And I am not the person to figure that out, obviously. Let's see. Oh, so you don't assume, just because this looks like a right angle, don't assume it is. 89.9 degrees looks like 90 degrees, but that building's going to fall down. So, you got to have the right angle, or again, they have to give you enough that you know it and you can figure it out yourself, or they'll just flat out tell you it's a right angle. So don't assume any of that. Don't assume a right angle. Don't assume congruency. None of that stuff. All right, so last problem. If the measure of angle BCD is, so this angle right here is 2x plus 7 degrees, and the measure of angle DCE is 3x minus 11 degrees, the measure of angle BCE, okay, that's the big angle, so this whole measure is 76 degrees, then we'll just use the angle addition postulate. I know that the two measures of those two adjacent angles should end up giving me that big angle. So that's going to give me 5x minus 4 is 76. 5x plus, okay, 76 plus 4, there's 80. X is 1, X is 16. Not what they asked for. They want the measures of these two angles. So BCD. So 2 times our X plus 7, 32 plus 7. All right, so the measure of angle BCD is 39 degrees. And then 3 times that 16 minus 11, so 48 minus 11, well, we got 37. So the measure of angle DCE, is that how they wrote it? Yeah. DCE is 37 degrees. There we go. And let's try again. Who knows if it'll work?